Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over part 1 of our AP Calc Help series on applications on differentiation. These tutorials will prepare you for problems 1 to 6 of the 3.1 section of the Larson AP Calculus textbook. The instructions are as follows. For the given functions, find the value of the derivative at the specified max or min, also known as the extremum. Alright, so for question 1, we have the graph given here. The function under consideration is f of x equals negative 2x to the fourth over 5 plus 3x to the fourth. Alright, so what we're going to do is we need to find the value of the derivative at the extrema of this function that's graphed here with the given function. Okay. All right. The solution is as follows. Let's start off by identifying what the extrema is. All right. The extrema, in this case, remember the word extrema is the singular form of extremum. Okay. So the extrema, we have only one here. An absolute max. An absolute maximum is located at x equals 0. So for this particular problem, this point right here is your absolute max. And it happens that x equals 0 and the value of the absolute max is 0. Alright? Okay, so now we've identified where the extremum is located is at x equals 0. Now we need to find the derivative at x equals 0. Okay, so the derivative at the maximum is simply f prime of 0. Okay, so let's look at the formula that we use to find the derivative at a point. Alright, actually the steps. So if you want to find the derivative at a point, so let's say you want to find f prime of a, there are two parts to it. Okay, so you're going to remember to do the calculus part first. So part 1 is to find the derivative of the function. Find f prime of x. Alright, and then after you're done with the calculus, then you can do the arithmetic part or the algebraic part. Alright, part 2, you're going to evaluate the derivative at the specified a value. So these are the two steps we're going to be using for the 6 problems in this presentation. Alright, so let's start off with the first part, part 1. We want to find the derivative. So part 1, we want to find f prime of x. Okay? Alright, so the function that we have, f of x, is given by negative 2x to the fourth over 5 plus 3x to the fourth. We have a quotient of two functions, okay, a quartic monomial and a quartic binomial. The first thing you might think to do is to use the quotient rule, but you do not want to be in a haste to apply the quotient or product rule. Always ask yourself, is there a way we can rewrite the problem to avoid using those rules? In this particular case, there is nothing we can do. There's no way we can rewrite it to avoid using the quotient rule. Okay, so we're just going to name the numerator portion u, and then the denominator we're going to call it v. Alright, so we have u over v. Now, what is the formula for the derivative of a quotient of two functions? So let's go ahead and review the quotient rule. U over v prime is equal to v u prime minus u v prime all over v square. Alright, so you have low d high minus high d low over low square, or low low. Alright, so what we're going to do is basically substitute u and v for, replace these functions for u and v in this formula, and then compute what the quotient is. Okay, the quotient rule. Alright, let's see. So f prime of x is going to be v is 5 plus 3x to the fourth. U prime is going to be the derivative of negative 2x to the fourth. So that's vu prime minus u, which is negative 2x to the fourth. V prime, which is the derivative of the denominator, 5 plus 3x to the fourth. And then this entire thing divided by the denominator squared, which is quantity 5 plus 3x to the fourth square. Okay. Alright, so let's go ahead and carry out the differentiation components. F prime of x is going to be the quantity 5 plus 3x to the fourth times the derivative of negative 2x to the fourth. You just power down and mark the power down by 1. So 4 times 2 is 8. So you have negative 8x to the, mark this down by 1, 3 to the third minus negative 2x to the fourth. And then this will do term by term differentiation. Alright, so the derivative of 5 is 0, and the derivative of 3x to the fourth, just power 4 times 3, that's 12, x to the third power. Alright, so that's vu prime minus uv prime. Divide the entire thing by the denominator squared. Now, one thing to keep in mind for the AP exam is that when you are evaluating the derivative at a point, you do not have to waste your time simplifying completely. Alright? As it is in this particular case, we're evaluating this function at x equals 0, so we don't have to simplify. We can just plug in 0, and that will be easier to compute. So we are now advancing to part 2, where we're going to evaluate the derivative at x equals 0. Okay, so let's go ahead and start plugging them in. We're going to have f prime of 0 is quantity 5 plus 3 times 0 to the fourth times negative 8 times 0 to the third minus negative 2 times 0 to the fourth times 12 times 0 to the third, and that entire thing divided by quantity 5 plus 3 times 0 to the fourth square. Okay, so we can easily see what this is going to be. F prime of 0 is equal to, this entire term here is 0, and these two are both zeros, 0 and 0. Okay, so the entire numerator is 0. It's basically 5 times 0 minus 0, 0 times 0 over, and then the denominator we have, this is 0 also, 5 squared, which is just 25. So we just have 0 over 25, which is 0. Okay, so the derivative at the extrema, which is x equals 0, is equal to 0. Alright, so there goes our answer for question number 1. Alright, let's take a look at question 2. We have a trigonometric function here. For question 2, let's say that the function f of x is sine of pi x over 4. Okay? Alright, so we want to find the value of the derivative at the extrema. In this particular case, the extremum, we have two extrema here. The extremum, an absolute maximum at, or an absolute max and an absolute min and an absolute minimum are located at, so the maximum is at 2, at x equals 2, and the absolute min, one of the absolute minimum is at x equals -2 respectively. Okay, so in this particular problem we need to find the derivative at these two extrema. Okay, so let's label it. This is your, in this trig function, you know how the trig functions behave. This is your absolute min at x equals -2, and then you have your your absolute max here at x equals 2. Okay, so the derivative at the extremum is f prime of 2 and f prime of -2. So we need to find the value of these two terms here. Okay? Alright, so we're going to first of all find the derivative f prime of x because it applies to both, and then we're going to evaluate the derivative at these 2 points. Alright, so part 1, we want to find f prime of x. Alrighty, so the function is sine of pi x over 4. Alright, so what we're going to be using here is the chain rule. Okay, how do we know to use the chain rule? We're using the chain rule because we have a composite function. We have an outer function, a trig function, and a linear function, a linear monomial as the inner function. Okay, alright, so to differentiate this, we're going to be using the chain rule. So derivative of the outer evaluated at the inner times the derivative of the inner. Okay, to help you out with that, let's just break them up. So let's call f of x the outer function, sine of x, and let's call the inner function g of x. Let's color code it. So the inner function g of x is pi x over 4. Okay, so what we'll do is differentiate both functions. F prime is derivative of sine is cosine. So this is like f prime of u. And then u is the inner function g of x, g prime of x. Now to differentiate this, just remember that pi x over 4 is the same thing as pi over 4x. Don't let that confuse you, okay? So the coefficient is pi over 4. We can factor out that coefficient and use the constant multiple rule to differentiate this. So the derivative of pi over 4x is just the derivative of x multiplied by pi over 4. Alright? So that's simply going to be the coefficient, which is pi over 4. Alright? So using the chain rule, the derivative of the outer cosine x evaluated at the inner, so we'll just take g of x and put in here. And then we'll multiply that by the inner function, pi over 4. Alright, so f prime of x is going to be the derivative of the outer evaluated at the inner times the derivative of the inner, which is pi over 4. We can put that in front over here. Bam. Alright, so we have the first part, which is the derivative. Now we're going to proceed to look for the value of the derivative at the specified extremum. All right, let's start with the smaller of the two, which is f prime of 2. So part 2a, want to find or evaluate the derivative at negative 2. Okay, so evaluate f prime of negative 2. Okay, so let's do it. Just plug in negative 2 here. So f prime of negative 2 is going to be pi over 4 cosine pi over 4 times what? Pi over 4 times negative 2. Okay? So if we simplify that, we're going to have f prime of negative 2 equals pi over 4 cosine negative pi over 2. Alright? So we can easily figure out what that is. We can use our cosine function to figure out what cosine pi over 2 is. Let's draw a small cosine function over here and figure that out. Or you can use a unit circle, whichever you prefer. Alright, so cosine has a max of 1 and a minimum of negative 1. And then that's pi over 2. Remember, cosine is like the cup function, right? So it goes like this. Bam, like that. Let me draw it again, make it look prettier. So it's concave down, like that, and then concave down. And then it goes like that. Alright, so this is negative pi over 2. We're going to use this now, and then we're going to use pi over 2 later. Alright, so you can clearly see that cosine, this is the y equals cosine x function. Cosine of negative pi over 2 is 0. Okay, so this is going to become pi over 4 times 0. And then the final answer, f prime of negative 2, is pi over 4 times 0, which is 0. Alright, so let's do the second part of part 2. So we're going to, in this part, evaluate the derivative at 2. Okay, so we're going to plug in 2 into the function. F prime of 2 is equal to pi over 4 cosine pi over 4 times 2. Alright, so this gives us f prime of 2 equals pi over 4 cosine. If you simplify that, you get pi over 2. And if you look at the graph here, you can see that cosine of pi over 2 is also 0. So f prime of 2 is pi over 4 times 0. F prime of 2 is 0 also. Alright, so the derivative at the extrema is f prime of negative 2, this is at the minimum, is 0. And then the derivative at the other extrema, f prime of 2, is 0 also. Okay, so there goes your answers for question number 2. Alright, let's take a look at question 3. So we have the function here, the graph of the function. So for question 3, let's say we have f of x equals x over 5 plus 5 over x. Okay, and the graph is graphed here. Alright, so the extrema, in this case, we just have an extrema. The relative extrema, or let's say the extrema is just is going to be a relative extrema. Okay, so the extrema, a relative, this is a high point, a relative maximum is located at x equals negative 5. Okay, so this is not the highest point of this function. It's just the local maximum. There's another portion of this graph on the first quadrant. All right, so this point right here is the is a relative max or local max, the relative max, and is at x equals -5. All right, so the derivative at the extrema, the derivative at the extrema is what? The derivative at the extrema is f prime of -5. So all we just have to do is follow the steps we indicated earlier to find the derivative of this function and evaluate it at -5. Okay? Alright, so let's start with part 1. Part 1, we need to find f prime of x. Alright, let's do it. So f of x is x over 5 plus 5 over x. So if you look at the first portion of this binomial here, are we going to use the quotient rule? The answer is absolutely not. There is a 1 in front of here. We can rewrite this so that we don't use a quotient rule. Now take a look at this 5 over x. Do we have to use a quotient rule? Can we rewrite this in such a way that we just use a power rule? And the answer is yes. How do we do that? Well, let's rewrite it in the following way. So we rewrite the function as 1 over 5x. So you see you have a coefficient here. Okay, plus I'm going to use the reciprocal property of exponents to rewrite this as 5x to the -1. So just by rewriting these two terms, we have avoided the use of the quotient rule. Alright, so don't be in a haste to use the quotient rule. Always ask yourself, can I rewrite it in such a way that I can expedite the differentiation process? Alright, so now that we've rewritten it, we're going to go ahead and differentiate. F prime of x is equal to derivative of, we can just factor out 1 over 5. You could do this mentally if you have your rules mastered. So we're differentiating x plus, and then we can factor out, you can always factor out coefficients from derivatives and integrands, okay? And then those are what we're differentiating. Okay, so what's the derivative going to be? F prime of x is going to be the derivative of x is just 1 over 5 times 1 plus 5, apply the power rule here, times -1 x to the, reduce the power by 1, so it's -1 minus 1, minus 1, minus 1. Okay, so f prime of x is going to become 1 over 5. If you simplify this, minus times plus, minus 5x to the -2. Alright, and then we can rewrite it further. F prime of x is equal to 1 over 5 minus 5 over x squared, using the reversal of the reciprocal property of exponents. Alright, we're done with part 1, which is to find the derivative. Part 2 is to evaluate the derivative at the specified extrema, which is -5. Alright, so f prime of -5 is 1 over 5 minus 5 over -5 square, which is equal to 1 over 5 minus 5 over -5 square is 25. Alright, remember when you raise a negative sign to an even power, all the minuses pair up and it becomes positive. Okay, and then you have 1 over 5 minus 5 over 25 is 1 over 5. You just simplify that, divide top and bottom by 5. 1 over 5 minus 1 over 5 is 0. Okay, so this one I divided by 5, and I divided by 5 to get 1 over 5. So we can see here that the derivative at the extrema, f prime of -5, is equal to 0. Alright, so how well have you mastered the contents of this presentation? To test out your skills, you can access some practice problems in the copy of the um, Larson AP Calc textbook. Okay, so practice problems are in the AP Calc Larson text. You just go to section 3.1 and do problems 1 to 3. Alright, so do those problems and see how well you've mastered the concepts covered in this presentation. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your studies of the AP Calc, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about what we covered in this presentation or any AP Calc topics in general, just place it in the comment section below and we'll be more than glad to support you. Don't forget to subscribe to our channel for the remainder of this intensive review series. More clips, tools, and prep resources can be found on mathgotserved.com. Go ahead and check it out. Thanks again for watching and have a wonderful day. Goodbye.